We are looking at question 2 on our March 2025 exam prediction. Now, in this question, we still apply our academic constitution that says I can. The I is for interpretation. Now, to interpret the problem, we'll begin by really reading the problem so that we can break it down and have an understanding of what is going on. The question says the table below shows 6 organic molecules, A to F. Now, when we look at our molecules, we have molecule A, which we can see it's actually given as an IUPAC name. We also have B, which is given as an IUPAC name as well. And on C, we actually are given a condensed structural formula. And D, we also have the same thing, a condensed structural formula of a different molecule, of course. And on E, we are given a structural formula of the molecule. And so is F, we have another structural formula. Now, I'm not going to do further interpretations by looking at each and every one of them and unpacking it, because there will be questions that will be specific to these molecules. So I'll look at the details of each molecule on the specific question. So that is to say, I'm stopping my interpretation at this stage. We are done with interpretation now. I will classify this problem as a problem that requires the knowledge of organic chemistry. And it's simple now, during your March exam, to do classification in terms of your exam or your questions that you do, because you only did one chapter in organic chemistry. However, when I look at these molecules here, the organic molecules here, well, I can see that the organic molecules really, because, I have the carbon attached to other carbons and non-metal atoms. But the other thing is that when I look at these molecules, I can see that the questions that I could get, will range from naming these molecules or drawing structural formulas of those molecules. Even when you have a name, they can ask you to draw a structural formula. Maybe you can get things like isomers here, because some of the structures, when you look at them, maybe they are isomers. We don't know. We expect such questions when we have a question structured in this fashion. Other things that you may be requested maybe could be based on reactions, because maybe some of these molecules, they react with something to form any of these other molecules. So those are things that I should expect in this question, the questions that I should expect when I classify this problem. Now, I can now go to answer the questions and see which part will they ask, but already I have an idea of what they could ask. And this is important, because even when you study, it means you need to focus on the things that they will ask you in these questions. Now we'll go and answer our questions. Question 2.1 says to us, define the term functional isomer. As I said, they could ask you about isomers here and stuff like that, because we are given structures that may possibly be isomers of one another. Now, a functional isomer really is an organic molecule that has the same molecular formula. But different functional group. So after answering your question, and mostly in chemistry, especially organic chemistry, the questions that you'll get will be conceptual questions, meaning questions where you have to explain, questions where you have to give definitions. We don't do much of calculations in organic chemistry. Now, the last thing that you do after answering the question is that you navigate the answer, meaning you look at your answer and see if there are no errors or any mistakes. So you literally will go through this, and then this question will be marked out of 2 marks. After you have checked everything and you're happy with it, you will be guaranteed to get a 2 mark question. Now, the other thing that we have to have in mind is that when they ask you a question of this sort here at the start, it means when you go down there, you might get something like functional isomers in your questions that follow. So let's go on to 2.2. They say to you, write down the molecular formula of compound C. So at 2.2.1, we are requested to get the molecular formula of C. Now let us go to a compound of C. Now, molecular formula, remember, it only shows the number of atoms that are in the molecule, the number of each atom that are in the molecule. So that means I literally come here and count each atom. So we start with carbon. As usual, you can see that I have 1, 2, 3, 4 carbons. So on 2.2, I'll have 4 carbons. And in terms of my hydrogens, I have 3, I have 5. Then I have the 3 again. So on top of 3, we add a 5. That should be an 8. So that means I have a total number of hydrogens to be 8. We also have an oxygen here. There are 2 of them. There are 2 oxygen atoms. And then that is really your molecular formula. And when we go to question 2.2, we're also expected to find the molecular formula of E. And when you look at the molecule E, we then actually can see that we have here 1, 2, 3, 4. We have 4 carbons, and we also have 1, 2, 3, 4, 5, 6, 7, 8. We also have 8 hydrogens. Then we have here 2 oxygens, 1, 2, and that is actually 2 oxygens. Now there's something very interesting that is really happening here. When you look at this molecular formula is actually the same for these 2 compounds. But when you look at the structure, we can see here that we have a different functional group. The functional group that we have here on C is actually an ester. Now, I don't know what method do you use to memorize your functional groups, but I'll share mine that I use. How I know that this is an ester is that I use a phrase that says that Esther loves to cook. Now, this ester here at the beginning here is my homologous series, right? It's the class that I'm dealing with. And this cook here is actually this OOC that we see in the molecule. So that's how I know ester is always given by COOC. So that's how I know that this is an ester. And obviously here we can see that we have an OH group. It's an hydroxyl group, which basically is an alcohol. This is an alcohol. So this functional group here is an alcohol. So what am I saying here is that I have the same structure. I have the same molecular formula, I mean to say, for these 2 compounds. But the functional groups are different. Here we have an alcohol. Here we have an ester. Right? We have a functional group of the ester, the homologous series of an ester. So that's why actually these 2 molecules are functional isomers to each other, because they have different functional groups but the same molecular formula. Now we will move on to question 2.3, which says write down the structural formula of A. As expected, if you're given a name, you could be requested to write the structural formula. Now, to do a structural formula, we then can go interpret further this name here of A. We can see here that our main chain is actually given by pentane. That means it has 5 carbon atoms. So this is to say that when I answer this question, I can begin by saying here, so we are doing 2.3, 2.3.1. I can say we have 5 carbon atoms in the main body. In the main body, we have 5 carbon atoms because we have a pentane, and they are all single bonds because our functional group here is an alkane. We then have the chloro on the third carbon. We have a chloro, a halogen at the third carbon. That means if I were to count my carbons from this side, I say this is 1, 2, and 3. Here on carbon 3, we actually have the halogen chlorine, and at carbon 2 we have a methyl group. That would mean that my carbon 2 would be here, since I said I'm counting 1, 2, 3 from left to right. So here we'll have our methyl group, and we all know that our methyl group is made up of 1 carbon, which will be attached to 3 other hydrogens, so that the 4th one will be this one. And from this point, there's nothing else that we have there. It means all the other bonds, they will actually be attached to hydrogen. But on top of that, there are other structures that you can draw where maybe you start counting from this side to say 1, 2, 3, and that means the chlorine will be here. But now when you say 1, 2, our alkyl group will be here on carbon 2 if we count from this side. Those are 2 other ways that will also be accepted if you draw it that way. But this one here, we call it a major compound, because if you look at the left hand side here where the chlorine is, we have 1, 2, 3, 4, 5, 6. We have the majority of our hydrogens this side, and this side we only have on the side of the alkyl group 1, 2, 3, 4. So we have the minority this side of our hydrogens. So this is what we'll call a major compound. So you can draw other ones, they are also correct. I have a memo of this question paper in the description of this video. You can download that memo and have a look at the other diagrams that you can draw or have. Now you can navigate this answer, of course, because remember, after answering here, you navigate, meaning you check if there are no errors. Always take a moment to look at if you have drawn your structure correctly, if everything is really fine, and fix where there could be mistakes and things like that, and make sure that at least your answer is verified and checked before you move to the next one. Now under our 2.3.2, they say draw the structural formula of B. We are now looking at B. So B, we do the same thing. Our main chain, or the longest chain, is actually made up of oct. Oct would mean that we have 8 carbon atoms. So here I'm going to have 1, 2, 3, 4, 5, 6, 7, and 8 carbons there. But these carbons, we're saying that at position 2 we actually have a double bond, because remember, this is an alkene group. That means we have a double bond. So if I count from this side, this carbon here on the left would be my first carbon 1, and this would be my second carbon 2. So my double bond should actually be here on carbon 2. So that's where we're going to have our double bond. But we also have an ethyl group on carbon 4, meaning on the 4th carbon. So we're going to say 1, we're going to count 1, 2, 3, 4. So on this 4th carbon here, we will attach an ethyl group. Remember, an ethyl group is really made up of 2 carbons. So that means this carbon here will have 2 hydrogens, and this one here will have No, not the hydrogen. We'll have another carbon because it's an ethyl group, and then obviously a carbon will have the three bonds there on the outside. Now we have put everything for ethyl. So on the fourth carbon we have ethyl, two any. So that means on the second carbon we have a double bond, and that would mean all of the other bonds that are left, they actually have an attachment of hydrogen. Now with this one here, we only have one bond, because remember the other valence electrons that were here, they came down here to make this bond, so we don't have the hydrogens here. Very important. And here we're going to have our three hydrogens, and this side we're going to have another hydrogen, because remember we have to have four bonds. And here already I have two, it means I already have two this side, it means I then have to add two on that side. The same is true here and here. Here we're going to have three on the outside because it's 1, 2, 3, 4 bonds. So now you can just put your hydrogens and your structure will look like this. Now again, this is one possible structure. There are other structures. You can always count your first carbon to be this side and numbering to go in that side. It means some of these things like the double bond, the ethyl group will move to this side, will draw them this side. It's the same structure. When you write the name, you'll get the same name. It's just that one would prefer to write it in that way, and in that order you will then have a major and a minor compound. Now again, as a rule, you will always apply your academic constitution, the end rule, where you look at the structure and make sure that you didn't make mistake. Sometimes people will put the hydrogen here. Just make sure, because now this is not possible. These bonds here, they actually are now removed and have formed another bond here, because one carbon will give us an electron this side, and also this side will form that equivalent bond there. So we don't have hydrogens here. So check such things if everything aligns and is correct. We are now going to then move to question 2.33, which says to us that write down the condensed. So we need here the condensed structural formula of A. So to write the condensed structural formula of A, it is not easy to do it from this name, because it's a name. It has a lot of things in there hidden in it. So it means you are going to go to a structure, because on 3.2.3.1, what we actually did is that we drew a structure of A. So you basically can look at the structure and you can now write the condensed. Remember, the condensed, basically we are, to condense, to compress something. We are compressing these hydrogens so that we now write them as things like H3. This would be the C and the 3 carbons. And here you're going to also have CH, and then we're going to put brackets to say this is a branch, this is an methyl group, and so on. So doing that on our 2.33, 2.33, we can see that the first part of it will be H3, as I said. Then the second part of it will be the CH. So here we're going to have a CH. It's only one hydrogen here. It's only one hydrogen, but we're saying this is also bonded to the CH3. When I put brackets, I'm saying also that it is bonded to this side here. And then we also have the CH. So we have the CH, which is bonded to the Cl, the chlorine. You can see this side, it is bonded to the chlorine. We also now have the CH2 and the CH3 at the end, because this one here has 3 hydrogens. So this will be the CH and attached to the CH3. So that is the condensed structural formula. Now, when we navigate this, we check if there are no mistakes and all that. If we double check, I have CH3, I have CH in bracket CH3, I have CH and Cl, then I have CH2. Now check here, I did a mistake here, I didn't write the 2. That's why it's important to navigate your answer. And then last part is CH3. So I realized that on the previous question also I didn't from 2.2.1 we have to mark this. So if you look at these questions here, it's just only 1 mark, because you're just drawing the you're just writing the molecular formula. And then if you come to 2.3.1, this one here, it is 3 marks. So I want to just, go through it to say what do they mark. They'll give you 1 mark for writing the methyl group, for writing the halogen, the chlorine, the chloro or chlorine, and then 1 mark for the correct structure, the whole structure. Right, so 1 mark for that. It is also 3 marks for B. So this question here, it is also marked out of 3. So this one again, they will give you 1 mark for writing the double bonds, 1 mark for writing the ethyl group, and 1 mark for having the correct structure, the whole structure, to say it is correct. And when you look at question 3.33, is just 1 mark, because here you're just consolidating what is on the structures. There isn't really a lot of things that we do there. So now we are ready to go to 2.3.4, which again requires us to do a condensed structural formula, but for B. Like I said, it's difficult to draw it from here. So we're going to look at the structure B, because we actually drew the structure B on question 2.3.4. So now when we go through that structure, which is this one here, we can see that we start off with CH3. So we have a carbon attached to 3 hydrogen atoms. We then have the CH. So here we have the CH. We also have another CH. So we have this CH and CH. Now, on the condensed structural formula, it's not the culture to write the bonds, but you can see that if I have 1 hydrogen and 1 hydrogen here, there must be a double bond here, because, normally it should be 2 hydrogens. So that's how we figure it out. We also have here 2 hydrogen, carbon and a hydrogen, sorry, but it is attached again on this side. It's like a branch that is attached to it to an ethyl group, which basically now we're going to represent it in brackets to say this is H2 and HC3. Do you see that we have actually an H2, CH2, I mean to say, then we also have a CH3. Then from there, it is attached to the CH2, CH2, CH2. We have 3 CH2s, CH2, 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 and at the end here we have CH3. We then have the CH3. So I don't have space, but you just try to write it in 1 line, so that at the end here, after the CH2, we have the CH3. And that's how you are going to answer that question. Again, it is 1 mark. You can always go through it and verify if everything is okay just before you jump to the next question. So you navigate this answer and see if you've drawn the correct structure. You didn't miss some of these hydrogens and the branch that is there and all that. Now we then go to 2.3.5, where we are asked to write down the structural formula of the functional group of compound C. Now when we go to compound C, we said that this functional group here is a cook, right? It's an ester, because ester loves to cook. Now this functional group, obviously we can see that here it will come out as a carbon that is attached to 2 oxygens. So how we draw this, so I'm on 2.3.5. How we draw this really is that you are going to have a carbon is attached to an oxygen by double bonds and also attached to another oxygen, right? And this oxygen could be attached to that C that we have there, or it could be any other organic molecule, and this side will also be attached to something else. That will be unaccepted. There are other 2 more ways of writing this. Again, download the memo in the description of the video and learn those other 2 ways, right? But really, this stuff, I believe also that in your textbook, it's just a matter of memorizing those functional groups. Then question 2.3.3 says to us that we should write the structural formula for the functional group again, but now of D. We are here on D, so D is this molecule. Again, I will give you a way in which I remember this. our functional group, I can see that it's here because, here we have carbon attached to 2 hydrogens, and, here attached to 3 hydrogens. But this one here, it's a functional group. I personally pronounce it as CHOR, and that's because I use the phrase again, or the mnemonic, if you like, that says all the days we do chores. Now, if we break this down, this part here that says all the days, for me it sounds more like aldehydes. All the days for aldehydes, and we get chores here, chore. So when I see chore here, I know that it is a homogeneous series or a class of aldehydes, right? And it is then given by that CHL. That's how I remember it. So this would then mean it is a functional group that would be defined or given by the structure that says we have a carbon attached to oxygen and we have a hydrogen. That's why they form chores here. But there will also be another bond here that would want to bond to other molecules on the left hand side. Again, with this one, there are other structures that are similar to this. You can check them on the memo. Some people like to write an R here to represent other organic molecules that can combine. So that's another way of writing it. Some people like to collapse these two and sort of write it like this to say this is CH attached to O. So those are other structures that you can draw here. Now we are going to do question 2.4, which says that write down the IUPAC name of the compound. So the first one is compound D here at 2.4.1. 2.4.1. So we are doing 2.4. Now, the best way actually of answering this question is to actually write the structural formula of this for you to be able to see it. If you are able to write it using a condensed structural formula, that's fine. But I find that the easy way is to actually write down the structural formula where we are going to say we have C, and we also have another C here. And we said that this is the chores that we always do. That's how we know that the functional group is actually carbon attached to an oxygen via double bonds and also attached to an oxygen. And here we can see that we have 2 hydrogens and 2 hydrogen, another hydrogen there, and then here we have 3 hydrogens. Now when we look at this structure, it is evident to us that it is actually made up of 3 carbon atoms. That would mean that it's a prop. Our prefix, meaning the first letters of our name, would be a prop. So we'll begin by writing here a prop because we have 3 carbon atoms. The other thing that we note here is that we actually have there are no branch chains, and everything is a straight chain molecule. And then we have the functional group here that is defined by the ester, and we know that ester has a suffix anal. So that means we're basically going to combine this prefix prop and anal. But now you may like, so this will be propanal. Some people may like to put the position of where this functional group is actually taking place. So that means this name can still be written as prop, and then I will then say where is the functional group. Now to get the position of the functional group, we're going to count our carbons in the main chain here, in the longest chain, from the side that is closest to the functional group. So the functional group is this side. That means we're going to count this as carbon 1. Let me use a different pen to count them. So this will be carbon 1, this will be carbon 2, this will be carbon 3. So that means here we're going to say our functional group is on carbon 1. So that means I'm going to say here 1 anal, like that. These are exactly the same names. It's easier in this case to actually, leave it at this, because we only having our functional group at the end of the molecule. If it was here in the middle, it will only have one name, where it will be prop 2 anal. So in this case, either of these are accepted. Now, if we go to the next question, which is 2.4.2, okay, maybe we can talk about marking this. I don't know why I forget about marking this. 2.3.4, 2.3.5, okay, 2.3.5, this one here, we didn't mark that. It was out of 1 mark. Basically, you just writing your functional group. Even here is 1 mark. They will just check if everything is okay, the bonds, the atoms, and also this one, it is for 2 marks. So here basically, it's just 2 marks for giving the name. So basically, we're saying you should spend about 2 minutes putting your rules in one place and answering that question. So we're going to look at molecule E. If we look at molecule E, we already said that it has a functional group of an alcohol. So that means our suffix will be, our name should end with an OL, right? But the other thing that we notice is that we have 2 hydroxide groups, we have 2 alcohols, and because there are 2 of them, we then gonna use another suffix that says di. So they're going to be diol. Di means 2. Remember, we have mono, which is 1, then we have di, which is 2, and so on. Now in this case, because there are 2 of them, is going to be di. But the other thing that we have to notice is that we have a straight chain molecule. There are no branches here. And when I look at my carbons, I have 1, 2, 3, 4 carbons. That would mean that this would be classified as a bu. So this is it has to be a bud, because bud means 4, right? So it means we have 4 carbon atoms. But to that end, I can see that we also have a double bond. So this means that here we're going to have also an ENE, right? To mean that this is an alkene group. It's an alkene group. It's an alkene group. It's a double bond. Alkene will be double bond. But now the other things that we have to then put are the positions. Here I have to specify the position of this double bond, and also here I have to put the position of the alcohol. Now to do that, again, we are going to count our carbons in the main chain, in the longest chain. And when we count them from the carbon that is close to the functional group. Our functional group here is this one here, and the carbon closest to them is actually this one here. So it means this would be carbon 1, this would be carbon 2, this will be 3, and this will be 4. That means if I want to specify the position of my double bond here, the N here, I will say it is at 1, 2, 3. It is at it is at 1, 2. It is here at carbon 2. So that means here I'm going to have a dash and a 2 and a dash. Then if I want to specify this part here, which is my alcohol, I will say it is at position 1. I have the first one there. So this would be 1 and then comma. Then we have the other alcohol here at position 2. So that means it will be comma 2 and then you put the dash. The whole name will be a bud 1 any 1 2 diol. So that is the full name that I'm going to put here. It's going to be a bud 2 any / 1 2 dash diol. All that it says here is that we have a straight chain that has 4 carbons, and at position 2 we have a double bond, and at position 1 and 2 we also have functional groups of alcohol, OH group, the hydroxyl group. That's what this name basically says. There are other ways in which you can rewrite this name. Feel free to use those names as well. It's just an arrangement of these names if you know other methods. The last question here, which is 2.4.3, says we should write the IUPAC name for F. Now when we go to molecule F, we can see that again we have a straight chain molecule. It does not have branches and it is made up of 3 carbons. That would mean that we actually have a prop again, because prop would mean 3 carbons. And the other thing that we note here is that we don't have single bonds. We don't have double bonds, it's a single bond, I mean to say. So this means it's like a propane. But there is a functional group as well, and our functional group here is the group CO. CO is attached to the carbons there. And we know that this functional group is actually a keton. When you have a C attached to carbon, this is a keton. So we know that with a keton, our suffix, the name of our compound should end with anon. We should have anon at the end of our name. But again, we have then to put position of this functional group to say where is it positioned. Now when you check this molecule, you can see that I only have 3 carbons. So whether I count 1 here, 2, 3, I will still get the same name even if I count 1, 2 and 3 from this side. So I'll just choose any direction. You can explore it from the other side. I'll say this is 1 for me, this is 1, this is 2. You can do 1, 2, 3 and see if you get a different name. I think we'll get the same name. If you get a different name, there should be a problem or mistake that we are doing. So now this would mean, I would say that on carbon 2 we actually have our functional group, which is the anon, the keton. Now the homologous series keton, not necessarily the functional group. So now this would mean if I combine my whole name, we will actually write this as a propane. So I'll cut this part, it will be a propane. Wait, no, I'll cut the E here, it will be a propane and combine it with the anon so that it becomes a propanon, right? So our name would be exactly that. It will be 2.4.3. It will be a propane. Then I will put at the end the non, it will be a propanon. But again, some people, as I said, they like to specify the position of this functional group to say where it is. But for this molecule, really, it will always be the same because we only have 3 carbons. So that is to say, you can also still say this is a propane and say at carbon 2, here at carbon 2, we have the functional group of 1, so it will be a propane to 1. That's another way in which you can write this. There is another interesting way which I like to share with you that we can name this particular compound. One can look at this compound from an angle that it is actually a functional group of CO that is attached to an ethyl group. Do you see that this is, no, not ethyl, but methyl? Do you see that this is a methyl group? And also this side, we also have a methyl group. So we're saying that we have a functional group CO attached to 2 methyl groups. So we're having 2 methyl groups. We have a methyl group and there are 2 of them. When there are 2, we call this di. So we can say this is a dimethyl, but we say this is a keton. We are saying that this functional group is a keton. So this means the name can also be rewritten as dimethyl keton. Is a keton that has 2 methyl groups attached to it. That's another way in which you can name this. I don't know if they've shared with you that rule or something new, but that's another way in which you may name that compound. So that will be how you score your 20 marks. You would see that they give you 2 marks for naming all this because they will just check if your positioning is correct, if your number of carbons are correct. So for this one, I think actually we will have another group in terms of another mark in terms of looking at your functional group. So the same is true here, 1 mark for number of carbons and your functional group, or just 2 marks for that. It will depend on which name you have right hand. We are going to then look at question 3.